Hello, my name is Ayushi Dubey. I'm more of the Azure cloud enthusiast. I love to explore the Azure technology. With each coming days, I try to learn new and relate it with real life scenarios, to build the end-to-end solution. Recently, I have cleared the CK exam of Kubernetes and 13x Azure certification, which I did earlier. I would like to thank the Azure Developer Community for giving me the opportunity to share my bit of knowledge on this platform. Thank you. So, starting with my topic, welcome to the world of digitalization. With comprehensive evolvement and ease to technologies, we have become more prone to the techie world. As technology becomes increasingly sophisticated, so are the hackers, continuously working on new ways to exploit and compromise it. We can see now the invisible world of dark, hidden, exploited digitalization. Let's say example with NSG, ASG and standard tier of firewall, you can't detect the intruder. You can't achieve more visibility into it. Some statistical figures of cyber attacks will prove it. Like recently, endpoint threats, which blocked more than 9.6 billion malware threats targeting enterprise and consumer customer device. Then email threads, which was blocked for Microsoft Defender for Office 365, blocked more than 35 billion phishing and other malicious email targeting enterprise and consumer customer. Then identity threats, that is Microsoft Azure AD detected and blocked more than 25 billion attempts to hijack enterprise customer accounts by brute forcing stolen password. Today, organization needs a new security model that more effectively adapts to the complexity of the modern environment, embraces the mobile force, and protects people, devices, application, data wherever they are located. This is the core. So basically, it teaches us never trust and always verify. My topic will be implementing the zero trust network for web application. An agenda study and demonstration of network security services like Azure Firewall and Application Gateway, when to use this each of the service and the network option for when we combine both and how it can be benefited as a security option for your organization. Azure Firewall is a cloud-native and intelligent network firewall security service that provides the best suite of threat protection for your cloud workloads running in Azure. It's a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. It provides both east-west and north-south traffic inspection. Application Gateway operates as an Application Delivery Controller (ADC). It offers TLS, previously known as Secure Socket Layer, termination, cookie-based session affinity, round-robin load distribution, content-based routing, ability to host multiple websites, and security enhancement. This protects your web application from web vulnerabilities and attacks without modification to backend code. Now let's see if your business organization is using a firewall only, then how it will be. Here user tries to access the web application via firewall. So the firewall inspects the packets. This is the flow of the firewall if you are using in your architecture. It will control both inbound network traffic to the application and outbound traffic. The functionalities provided by Azure Firewall can prevent many attacks like IDPS, data exfiltration, etc. and so on. But Firewall can't give you the web-based advanced security like of prevention of cross scripting and SQL injection. So there comes in the picture application gateway. If your business model is only using the architecture which includes application gateway only, here it will be like client accesses the web application using the public IP address of the application gateway. This will be the flow. But here application gateway alone, when only web application are in the virtual network and network security group, provide sufficient output filtering. Likewise, here if you are using application gateway in your model, so it can't detect intruder because it is a part of the firewall. It detects the intruder and IDPS, that thing. So basically, if you want to manage the non-HTTPS traffic, use Azure Firewall in your model. And if you want to use the HTTPS and if you to manage the HTTPS traffic, so use application gateway. But what if your requirement is for both Azure Firewall and application gateway? Then the business model can be firewall and application gateway in parallel. Here you will see the same flow of the traffic and the packet flow. But the difference is in your business model, for the inbound traffic, application gateway is dedicated, and for the outbound traffic, Azure Firewall is dedicated. This is one of the best scenarios because of its simplicity. So zero trust model is the best practice to always encrypt data in transit to achieve end-to-end encryption. However, from an operational perspective, customers would often wish to have visibility into their data as well to apply additional security services on encrypted data. Azure Firewall Premium with its transport layer security inspection, that is TLS, can perform full decryption and encryption of the traffic, giving the ability to utilize intrusion detection and prevention system, that is IDPS, as well as providing customers with visibility into the data itself. Azure Application Gateway with WAF benefits, that is SQL injection protection, as discussed earlier, cross-site scripting protection, protection against other common web attacks such as HTTP request smuggling, spitting, violations, inclusions, etc. But to achieve that model with the zero trust, you need to go for this. Like you have Azure Firewall and Azure Application Gateway in your model, but you need IDPS also. Yes. So deploy Application Gateway before Firewall, where you want Azure Firewall to inspect all traffic and that is Web Application Firewall to protect web traffic and the application to know the client's source IP address. With Azure Firewall Premium and TLS inspection, this design supports the end-to-end SSL scenario as well, with which we can achieve our zero trust approach. So, I will be demonstrating using the application gateway which will be acting before the Azure Firewall Premium, an application gateway with WAF enabled. So this will be our structure for our deployment. So we will be following the hub scope topology, where in hub VNet there will be a firewall named as FW1, and in spoke VNet there will be application gateway and the web server. We want like where we want not this flow that user is accessing the web application using the application gateway. We don't want this direct connection. We want that the traffic should go that the traffic should go just a second. Hmm. Traffic that user accesses the web application, but traffic should go via firewall, then web server. So the flow will be this way. Okay. It is using the application public IP address. It sends the request to firewall where firewall inspects the traffic. Then it forwards the request to the web application, and finally the client is able to access the web server. For connectivity of both the VNet, we will be doing the VNet peering, and to make the route as per our changes, like it should go from application gateway to firewall. This way it will configure the route table like UDR, user defined routes. For segmentation of network between web 1 and SQL 1, will configure NSG, VMNSG, and yes, for storing of data and logs, will configure log analytics. It will monitor our Azure application gateway and Azure firewall. Also for TLS communication, TLS collection between all these three resources, will configure keyword, and from there will configure the certificates by which we will be able to achieve our zero trust model. So let's start the deployment. Coming to portal. So starting with the deployment of firewall, which is under the hub VNet, means its subnet is under the hub VNet. Create firewall. We need to create the resource group. Let's name it as Zero Trust AG Firewall RG. A resource group is a logical container where our resources will be stored. Name it as FW1. Region will be selecting East US. Premium, our tier is premium, which supports the SSL termination and IDPS, ID prevention system. We need to create the firewall policy, FW pol 1. Okay. Name VNet as Hub1, Hub VNet 1. Address space 192.168.0.0/16. Firewall uses namespace with Azure Firewall Subnet. 192.168.100/24. Public IP address for firewall, FWPIP. Okay. Review. Create. By then firewall is creating. Let's start the deployment of application gateway on other tab. Application gateway. Create. We can see our resource group Zero Trust AG Firewall RG, AG1, East US. The tier we want is WAF version 2, that is Web Application Firewall. WAF policy, WAF pole 1. Okay. Create new virtual network, like the name will be Spoke VNet 1. Address range of 172.16.0.0/16. Subnet, name it as AG subnet. AG subnet. Same network 172.16.0.0/24. Perfect. Okay. Next, front end. Add new AGPIP. Okay. Public IP address of application gateway. Configure backend pool where our backend server will be targeted. BP1. Adding without the backend server, as we have not started the deployment for web server, so we can add them later. Add routing rule. Rule 1. Priority as 300. Listener, I will configure like it forwards for traffic to port 80. We'll do HTTPS later. For now, adding the rule for port 80. BP1, that is our backend target. Backend setting, add new H80. Add. Okay. Adding the routing rule. So front end routing rule, backend pool configured. Next review plus create. So it's starting for creating of application gateway. Here you can see the application and firewall, both are firewall got deployed. So now I will configure log analytics. Create log analytic workspace. Here the data logging offered by Microsoft and other services like Azure Monitor and Sentinel, Microsoft Defender for cloud. Select your resource group, Zero Trust AG Firewall RG, name LA1234, review plus create. What happened? Law 4321, I have named this log analytic workspace, review plus create. Starting the creation of log analytic workspace. Also, we want key vault to configure the TLS connection between our three services, three resources. Key vault. Region East US, pricing to your standard. Review plus create. In our scenario, we will be using key vault for storing of certificate. To get the access of this key vault, we need to configure the manage identity. So manage identities, create, select your resource group, name it as MI08. Review. Plus create. Our key vault is created. Access policy. Add access policy. Configure template which assures that key secret and certificate management. Permission is assigned. Select the principal to whom you want. Selecting our manage identity. Select add, save. So this is what is updated in access policy of key vault. Now let's check whether application gateway is deployed or not. Yes, the deployment is complete. Go to resource group. See all the resources what all are deployed in our resource group. Application gateway, firewall, key vault, log analytic workspace, hub 1, spoke 1. Okay. The two VNet are configured, but to enable the connection between these two VNet, we need to configure peering between them. So in hub VNet, going to peering, add the link name as such from hub 1 to spoke 1. So naming it as H1 to S1, making it bidirectional. Spoke 1 to hub 1 also. Select the virtual network, spoke VNet 1, add. Peering is added in hub VNet, and same you will find in spoke VNet 2. Now after this, we'll configure the web server, our web VM, virtual machine, create Azure virtual machine, resource group, name it as web1, East US, image as Windows Server 2019, standard DS1 version 2, enter these username and password. OS type standard SSD. The virtual network is for web server is spoke 1. Okay, it's not reflected yet. We need to reload it, or it will reflect in some time. Just reloading it again. Let's check whether it's reflecting now. Networking. Still it's showing the hub VNet. Okay, let it be. We'll wait some time. Till then we'll do the other part, that is on firewall. We'll enable the TLS inspection because it takes some time in deploying. TLS inspection, enable Here it will use its key vault. Okay, it's manage identity and key vault its certificate. It will be, see here you can read, where the CA certificate and primary are stored and auto generated. Okay, after enabling this option, manage identity. So this will take time. Now we'll leave this as it is. Coming to next tab. I will configure routes now. Route table. Also, one more thing we are missing is we need to create the web subnet also. Virtual network, spoke vnet, subnets. Here we have AG subnet. Also on this vnet we have one more shared resources, that is other subnet, that is our web subnet, our VM subnet, because we have SQL also. So we can't name it as web subnet, name it as VM subnet. So subnet address range, right, save. Now let's create route table. Create resource group, zero trust AG firewall RG, naming as RT1. The request will go from this request route will go from application gateway AG review plus create. Oh, my videos. I hope you can see me. Create. Now creating another route table that will go for VM. By then trying again the virtual machine. Still it's showing up VNet. Okay, coming back to the route table page. So one route table it's created. Go to resource, route, add. This will be for VM via firewall from AG. Select source, IP address, IP 172.16.1.0/24. Next hop will be virtual appliance, our firewall, the private IP of firewall. It is of network of 192.168.100.4. Okay, add. Subnet. Here will associate virtual network, spoke vnet 1, AG subnet. Okay. This was RT1. Now creating RT2 for VM. create, select resource group, naming it RT2, VM, review, review plus create, creating. So deployment is complete. Go to resource group, resource, route, adding the route for RT2, naming it as application to application gateway via firewall from VM. IP address 172.16.0.0/24. Subnet range of application gateway. Virtual appliance, private IP of firewall, add associate the subnet, virtual network, spoke vnet1, VM subnet. Okay. Now I am trying again to deploy the web server, web VM, create Azure virtual machine, networking. Let's check. Yeah, it's reflecting now. Spoke vnet1, resource group 0 trust AG firewall RG. Name it as web1, East US, Windows Server 2019 data center, DS1 version 2. Use VM. I don't want the port 3389. Standard SSD. Next. It was showing now. Again the same problem. After reloading again, now I can see the spoke VNet. It was the problem at the Microsoft. Sometimes it takes time to reflect the virtual network, although it is already deployed. VM subnet, it has selected the subnet what we deployed. We don't want public IP for VM, okay, because for it will access the web application, it will access from the application gateway public IP address. So we don't want the public IP for virtual machine for our web server. This is for the network segmentation. We are using this network security group between web VM and SQL VM. Next, review plus create. Creating. Web VM is deployed. Go to the resource, web VM. As we have not assigned the public IP address to the web VM, now how you will, for management of the web VM, how you will take the RDP? For that we can create the DNAT rule in firewall. So from firewall public IP configuration, we will be able to take the RDP for web VM. So for that we need to create first DNAT rule, copying the firewall public IP, firewall firewall policy 1, DNAT rule, add a rule collection, DNAT collection 1, sorry, DNAT C1, 200, DNAT collection group, allow RDP to web, IP address, source, any, protocol TCP, port is 3389, RDP port, destination. Here you will enter the firewall public IP address. Translated address will be private IP of web VM, that is 172.16 1.1.4, right? Yes. Translated port 3389. Add. It will take 2 to 3 minutes to create. Till then, let's deploy the SQL VM, our SQL server. Deploying of Azure SQL. Azure SQL create SQL virtual machine. Selecting this image, that is SQL Server 2019 on Windows Server, but free license. Create. Select your resource group, virtual machine SQL. The region is East US. Standard DS2 version 2. Username VM. Entering the password for our SQL VM, SQL account. None. Virtual network. It is under Spoke VNet 1. VM subnet. No public IP. No public IP, and yes, we want the basic NSG for the segmentation between the SQL and web. Next, management, advanced SQL, connectivity, private, SQL authentication, enable, review, create. Creating SQL VM for the backend database of for our web server. Okay. So switching the tab back to virtual machine, that is web 1. Here I want to install the IS, which I can do from the run command to run PowerShell script. Pasting the script, run. This will take some time, 4 to 5 minutes. Shift to another tab. A SQL VM is getting created. Let's go to application gateway. Application gateway, AG1, listener, configured, rules, assigned to listener port 80. Did we assign the backend pool? No. Target 0. So let's add the backend pool. Yes. Virtual machine. Target VM1, web1. Save. Now our web1, our web server is the under the target VML web backend pool. Refresh. Resume. Our SQL VM got deployed. Coming to log analytic workspace. We deployed it earlier. Yes. Firewall. Firewall 1. Diagnostic setting. It will send the logs to our log analytics, that is the LAW 4321 located in East US. Saving. I have selected all the logs. Coming to application gateway. Application gateway. Enabling the diagnose settings, same here like we did in firewall. Add diagnose setting. Name it as tag2. Selecting all the logs category group. Send to LAW 4321, our log analytics. Save. Now let's take VM RDP. We created a firewall rule in firewall policy, create a DNAT rule. So now let's check, are we able to take a RDP for our VM using the firewall public IP address, essential dropdown, RDP, entering the public IP address of firewall, connect. It got connected. VM admin. Entering the password. Yes. So we are able to take the RDP by using the firewall public IP address because of the DNAT rule. So we are able to take the RDP for web VM. Let's check whether IIS got installed or not. Check on its local host. You can check from its web one also. Web one. IIS got installed. Okay. So back to portal. Now we'll go to the resource group. Through resource visualizer, you can see that what all resources have been deployed under what? A flow. You can see the application gateway, firewall, spoke VNet, hub VNet. You can see the flow, the components what we have deployed till now. Now our next step will be checking the application gateway. We checked that the from web 1 from its local host we were able to check the our app what we have installed IIS. Now from this using the front-end public IP address of the application gateway, let's check whether we are able to access the web server. Paste, and it should forward traffic to HTTP based. Yes, we are able to. Now we need to. So now we'll create a new rule in application gateway and where it will forward the traffic from the HTTP based. Also, we need to configure the certificates both on web server, application gateway, and firewall. We already we enabled the TLS inspection. Let's check it whether it happened or not. Firewall, firewall policy, TLS inspection. Yes, it's enabled, and also the certificate has been loaded and everything is done on the firewall. Now let's configure certificate on application gateway and web server. Application gateway, AG1. First we'll create the listener. Add listener. Let's name it as L443 front-end, 443 front-end IP public HTTPS 443. Now choose a certificate from a keyword. But we need to first download the certificate from keyword. So switch to next tab, keyword, certificates, generate or import. We are generating the certificate. Cert name as here DNS label name of application gateway. So switch to one more another tab. Where I have to go to application gateway. I need to add it DNS name label. Go to public IP of application gateway, configuration, here DNS label, okay, AG1, copy this, go to certificate page, paste the name of AG1, then we don't need the public IP address. From this name, DNS name of this application gateway, we can access our web server, our web page. Paste, OK, policy configuration, create. So certificate has been created. Go to certificate. Download in CR format. Keep. Download in PFX. Done. And so now switch to again listener part. We were configuring the 443 listener. Cert 1. Manage identity. Key vault. Select the certificate we downloaded. Cert 1. Add. Refresh. It's creating. Backend setting. Add a backend setting for HTTP3, HTTP2, HTTPS. Name it as H443. Certificate. Open. Name it as Cert1. Add certificate. Save. So it's updating the backend setting and also the listener. Now I want that rule should the route which we configured earlier for port 80, it should forward for 443. So rules, rule 1, select 443 listener, backend target, backend setting, 443, save. Also, it should override the host name through host name, backend setting, 443, override with new host name. Save. Now we configure the certificate on application gateway. Now same has to be done on the web server. So going to the RDP machine, folder, downloads. Pasting the same certificate which we downloaded for application gateway from Key Vault. Install PFX, local machine, next. Place all the certificates in the following store, browse, personal, okay, next. Finish. Import was successful. Back to portal. Server manager. Tools. IS manager. We have imported the certificate but not binded yet to the web server. So we are editing the binding. Add. HTTPS. Application gateway hostname. SSL certificate. Okay. So on web server also we have configured the certificate. Now back to portal. Application gateway. Now let's try to access this host name using the HTTPS, whether it's forwarding the traffic to HTTPS or not. New tab. We are able to access the web page using HTTPS. Here our backend SQL database server is also connected to our web server, so all the record, all the everything will of the customer's data will be stored in this, which is attached to the web server. Let's create one record. Create. So one record has been created in our customer database of our web server. Now assume that attacker is trying to attack on your web server using a malicious code, stating as this is SQL injection. Okay, so let's try it. copying one of the malicious code and trying to attack it on this web server. So we are the attacker now. Let me try again. Assume that the attacking is going on. How you will prevent this? See, on log analytics, you can check all the logs which are getting collected from which is coming from the Azure firewall and the application gateway. But for this such attack here, we can go in the WAF rule, application gateway, go to resource group, go to our WAF policy. This was on the detection mode. Switch into prevention mode. So when the attacker is trying to attack with its malicious code on our web server, the request will be forbidden. So now go again and go to our web page and try again. Now I will try again to do the SQL attack, SQL injection attack. Search forbidden. Because of the WAF rule, WAF policy, prevention mode, it prevented the attacker to go inside our web server. Now let's go to portal and check the logs. Azure firewall logs. We can run the query here. I will run one of the query, that is Azure log data. This will give me all the data collected from the Azure firewall in the log analytics. Such what the beauty of Azure monitoring. There are more services like Azure Sentinel, same, which you can prevent the threat intelligence and such malicious attack on your web server. So you can see last 24 hours. With this, let's go back to the PowerPoint to check our flow. So we were able to build this architecture and we connected all over them with the TLS connection. We configured the certificate on Azure Firewall, application gateway, Azure virtual machine, from client to application gateway. From client to application gateway, then from application gateway to Azure Firewall, and then Azure Firewall to web server. This is how the TLS inspection took place. Means don't trust any of the packet, verify all. This is what the main aim of Zero Trust is, and we built it. With this, I end my topic. So if you have any query, you can connect me on LinkedIn, and I will be looking forward for the valuable feedback. And let's grow and prosper with Microsoft Azure. Thank you. Have a great day.